ready, click it, go live, everything's ready. Alright, everything should be fine. Oh. We're back to Kinematics. Took a while to get back here. What? Huh? Captions are doing magical things again. Anyways, starting from before. Oh yeah. I learned that I finally figured out that apparently the DVT is only usable for with the acceleration is 0. So there's no acceleration in constant velocity. Constant velocity, yeah. And otherwise you have to use the other stuff. I can't believe it took so long to learn that. But now I got it, I think. Anyways, question for you. Pilot is flying a jet engine, okay. I'm gonna draw it. Okay, so there's a plane over here. That's a plane. Don't worry about it. Okay, so it's velocity. Wait. That should be velocity. It can be speed. We'll leave it the speed 1500 km. Excuse me. kmh. The height of this distance is 35 meters. It doesn't seem very high. It doesn't. Okay, initially ground level, okay. There's the level. At time of 0, so this is so T0. T0, well I T0, subscript. You know, some should be understood here. Okay, so there's a slope. Yeah, I mean, one more. Okay, slope of theta, which is 4.3 degrees. So at what point do we smash into it? Well, if we use the rule, well, first we need to remember. We need to remember. This is also yeah, theta is also 4.3 degrees. That's okay. That's not good. That may be useful. What time hit? So this is 0s, and smashing time is at some time. By the way, this is I. I guess that's also the final. So we can presume that acceleration is 0. If you're assuming constant. Could we just use the v equals dt? No. We need to figure out when the slope here, when this becomes 35. We need to figure out when the slope becomes the height becomes something becomes 35. Well, we can probably say 35 here as well. Just to start figuring that stuff out. Ooh. At some point it becomes 35. Okay, let's just turn the 1500 kilometers to... No space there, no space there. Okay, 1500 kilometers km over inch. I believe it's just... No, it's 3600 as over 1000 meters. Yoink, yoink. And there's also the kmh, km... The meter. Meter. Well, point is, this becomes 1500 times 36. Wow. 6 over 1000, right? Right? I mean, I'm gonna make sure. Over 1 times km over 1000. Okay, I may have screwed it. Oh, yeah, there's a bit of flipped. Whoops. Yeah. 1000 over 3600. Cut out the zeros. And we get a cool 10 over 36. Let me just give that as a nice easy roundable number. Easy even number. Look at that. It's 1500 times 10 over 36. That is whatever. 116.67. Yeah, that's meters per second. Ta-da. That will work for the purposes of this. Okay. Okay, what if 35 over 416.67 equals sometime. When do we reach that? Wait, what? I don't think that makes sense. I don't see how that would make any sense. Yeah, I don't think that makes sense. Not yet, at least. It's sloping up. Sloping up a 4.3 degree angle. But sometime, at some distance, it becomes... But how do you abuse the triangles? This. Did I find the hypotenuse? Okay, why not? It's gonna be... Well, if I use this one, it'll be opposite the hypotenuse, so... Let's get some bunch of stuff here working. Sine of 4.3 degrees equals... I guess 2 times 35 is equal to h. Let's just say h. I don't know if that helps. I hope it do. I hope it do help. Sine of 4.3 big times 35. 2.26. H is equal to 2.26. Not sure how to help. Not sure if it helped at all. Wait, don't we just need to worry about the X direction? Very good. Very good. They could, but they could. When we use the tangent, let's just get the opposite adjacent. Actually, that's confusing. Okay, 2.6. Wait, what? What? Wait a minute. Hypotenuse can be slow, can be less than 35 meters, because it's the longest side. I'm getting suspicious here. I don't. Can't be. Can't be. It can't be. It would have to be something else. This is not working out. Opposite over hypotenuse. Oh. Would it be? I think it's division. Yes, wrong that. I think it's division, not multiplication. You fool. Because OH, not HO. That might explain my mistake. Well, but may or may not have gone even worse. But is it the opposite way? Alright, I'll not sure that's the answer, but if we do this away, let's do actually sine 3 equals over h times O over so no, that makes technical sense. Oh, but this would be right, this would be 1 over h. That's why it didn't work. H over 1 h, we can get h sine and then divide by sine, so we get O over sine of yeah. No, that makes sense. More sense. Less sense? That's no question. How much sense anything makes anymore? Alright, it was 460. What the fuck? What were you? You were 679 meters. Then That was just the hype of the news. Hype of the news. 4, 6, 7, 9. Oh wait, it's about 80 actually instead. Let's just square that minus 35 squared. Like the square root of that. Kind of 4.3 deck times 0.79. 80. The 5 squared. 5 squared. Wait, how can maths? Predict. And okay, okay. Screw it. Triangle calculator. What we're talking about the right triangle here this time around. Let's say 35. No, with 5 meters. Get your ways. I don't have it. Yep. I'm gonna say 1.3. 1.3 degrees. Wait. B really is 465 point whatever it was. So but I'm wrong. I was going insane. 6, 8. 4, 6 is 6, 8. No, 80 I suppose. 50. With everyone with zeros. Or 5. How did that help? You know? Who knows? Who knows? But we're technically saying that this you in the way, boy. This is the length. So that's the distance. But if we use that, I don't think that's helpful. Whoops, that's in the wrong one. That's the wrongest one. Well, it can't be because is it? Maybe something's working. Something. Wait, what am I using? I don't know what am I using. The bad bomb. Orders 466. Holy crap, I was right. Okay, so first of all, so big brain, so big brain, so big brain. So because I was right, we can use DVT, DVT. So we have 165.5 meters is equal to 116 point what? What's the speed? What's the speed? Oh, 6 meters per second times time. So divide I think meters is cancel. Yeah, meters cancel. And we are left with 7 and T. Or I'll make the T is equal to 1.117 seconds. Yes, I was correct. Oh, my drawing skill brain, so good, so good. I can't believe I've actually done something right for once. Usually my physics is all over the place. So this is a happy, joyous day. Okay, moving on. Moving on. 5. Ooh. What is it? Alright, next thingy. Good. Very cool. Right. That's number 4. Yeah. Number 5. The fire cannon. So, our cannon leaves some nice space here. Okay, cannon. I know my artistic skills are impeccable. Days, huh? Or 35 degrees. So let me just make a where's the break everything, huh? That works. If I can add a break toss. Okay, where should I put it? The I is cause 90 meters per second. I have a ball. Then this one, this boy is 90. Here. So T at 2 seconds. And the speed after 2 seconds. So basically we final. Alright, anyways. So anyways, we know they're gonna go because magic it's gonna go because science is gonna go in a parabolic arc. somewhere there is 2 seconds. Here in the way. 2 equal 2 in the way. I'm not gonna equal to s somewhere. But here. What's it here? Because the base case is that we have some Vy and some Vx. Because we need the... We also have that, and we have this. Those velocities. The Vx, Vy, velocities, or speeds in this case. No. Why this was given in velocity when it's when the answer is in speed. The answer that is wanted is speed. Anyways, here the important thing is this is when velocity y and the y is 0, but x is always constant because nothing affects it. At least nothing fancy in simple physics. Because air resistance is negligible. Negligible? Yes. So what? Okay, I mean it's just a goddamn triangle, isn't it? It's not a triangle. There are so many triangles. Can you believe it? But since this is the beginning, there's also a 35-degree angle there. If I throw the ball, it would be still 35-degree angle. And this is... Let me just screw that and say Vy, Vx, and I guess V. Those arrows didn't go so well. Anyways, Vx. We know, I mean, this is also 90. Doesn't matter. The Vx is, to find Vx, we gotta use cosine. It's V cosine 30, V cosine theta, and this is V, not cosine, this is sine of theta, because sine opposite over hypotenuse and adjacent by hypotenuse. Okay, we're good. So Vx is 90 times cosine of 35 degrees, which is something, and Vy, actually maybe I'll put Vy there. Vy equals 90 times sine of 35 degrees. That's a funky 5. Which is something. About something, I know that. Where are they? There they are. That's my Google for calculation. 90 times cosine of 35 degrees is... Please stop. 23.72. 3.72. It's technically meters per second on the bottom. We can all imagine it's that the meters per second is written there. Somewhere. Wait, come on. Bond. Tag. $51.62. 51.62. Wait, what's it? Or is it 63 closer? Which one? 62. 62 meters per second. Alright, we got that. This is 3.72. This is 51.62. That's good, that's good. So we know that Vx is always constant. Even here, well, even here, Vx is still constant. Vy has changed directions though. And this is still going somewhere. That's so important. Oh yeah, Vy, I mean, it could be draw it to scale. We could basically just have that Vx there. Equal. Okay. What do I need? What do I need to find out? I'm confused now. Oh yeah. What is that? 2 seconds. There's a mystery ball here. Okay, that's not a good mystery ball, huh? Boink, 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 boink. This is that where's just because. What is over there? But what is that halfway point? What is, okay, we can figure out the halfway point. How long did the halfway point take? The halfway point took some time. But how long? We don't have an equation for it. We have to figure out. God. We need to. One of the velocities. We don't have a distance, that's a problem. Do we need to find some distance there? We had 0 at the final point, so therefore it'll work. Let me write out the kinetic formula. It's we have because we owe a t VAT, but then there's delta x, we owe e times t plus 1/2 at squared. Then we have delta x equals we final minus we initial. I think you use O there, by the way. 2 times time. And this is supposed to be first, and then we have what's the last one? Wait, the last one. I actually can't remember. something, something, something. Kinematic in the list. Thank you, Khan Academy. Are you sure I have my ass here? Where's the list? Give me the list. Give me the list. Ah. Up there. Give me the list. Oh, there's the list. Weed final is squared, maybe. O squared plus, wait, what? Run it to a way deluxe. To a to acceleration times acceleration times the change in position. Okay. Technically not the initial. Come on. I think VO will be the I think it's something else. Oh. So let's do one thing which is we know what we can do, which is D equals VT can be used for the X. VXT, just to be sure. So we can have time equals D over Vx. We know we can have that. For the X direction. I think it might be time. Yeah, time. Where's the X? Ah. Does it help? We need the distance. How do we get the distance? Let me think. But why would initial be truly initial? No. Unless would it? I mean, we totally could, but does it help? Distance changing distance, huh? Oh. No. Wouldn't matter. What if I just try it? If we presume... Okay, we're gonna try the delta y. Because if the initial... Maybe we can do... No, it's not 90. 73... 3.72? 72 times... If we replace that, we get D of an X. Oh boy. Is it delta X? Or is it just distance? No idea actually. Let me check that. Uh, the song in um okay, no help from Google. Maybe ChatGPT can help me. Do you know? But how about you? Do you know? Hmm. I'm only interested in the displacement. We could just use X. Although I'm gonna use DX. I don't know if this helps. Velocity axis. Mm-hmm. Any more information, by the way? Mm-hmm. Yeah. Hmm. Oh wait, I probably shouldn't be using DX. That makes it look very much like a derivative. Maybe I'll use S sub X. Wait a minute. God damn it. 70 is for VX. You're 51.62 and 3.72. I'm sure there's a better way to do this. Plus 1/2 times, I guess, negative 9.81. That don't help. Oh, that one times S sub X. S sub X. 73.72. Where's my 2 disappearing? Red. That can't be good. There has to be something I can do about the S sub X. Well, it's the D or the S. Maybe I'll change the S here as well. It's not helping, is it? Hmm. Hmm. Uh, yeah, unless I can get rid of S sub x, I can't figure it out. Or I can, unless I can find it. I think I need time for that. What if I know the whole time? Equals something. Because in the y direction is 0. Me try something else actually. Okay, if we use the very first formula for y, we are y. Oh boy. Not equals plus at. Then we can have negative 51.62 all over negative 9.81, which is our time. So this is 5.26. This is a whole trip, by the way, I think. Whole trip around. This is from start to finish. Would it be? Would it? Am I right at all about this? I think I might be actually. And if I divide that by 2, I'd be at the halfway point. Oh yeah, I think I needed that. No, I'm not sure if this is useful anymore. What could be useful? Let me try the 2-second thingy. Wait, what would be Does this make sense? Wait, did I break something again? Don't know my average fine. Was this useful? Was this useful information? Is this even right information is still the question. Okay, let's figure out what's speed at 2 s's, right? We have y at, let me say, 51.62. We don't know the last one, but we do. Actually, we do. Actually, we can probably figure out times. No. Plus, wait, what is it? It's plus. Technically negative 9.81 times 5. Not 5 point times 2 is only equal to what? So we can find at least the y just for now. Plus 1 times 2, 32, about 32 meters per second at S2. We know that this is at least 32 meters per second. Now we're gonna just find the x. The velocity in the x direction, what would be? Boing, 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 boing. Delta x. Would it work? Let me just screw it. Have the shit. Now wait. What troubles me is that technically for the x, this stays constant. Everything would zero out in the first equation. Can it use the kinematic formula in the first place? Wait, maybe you can figure out the distance for x using... Maybe for this, we can actually use... What is it? 3.72 times 2, right? The distance is 144 something. What was the kinematic formula again? Burn. 72 times 2. 147.44 meters. This is after 2 seconds. I mean, oh wait, why am I thinking dumbassery? This is 73.72 in the first place. It never changed, right? Like, will it? Well, now it's the moment of truth because I do have the answer, so I should be able to figure out how much I've screwed up. Square root 80 point. Okay, so if we have oh boy, what in this universe VT for total. V sub t for velocity total is 73.72 squared plus 32 squared all over the square root is 80 point whatever what in the universe it was, whatever it was, 80.36 meters per second. That is actually correct. Okay, what is it? What is 37? 6, 9, 6, 365 technically. Could say so. I mean, you could say 80.40. Okay, that was a lot of nonsense for a simple answer. Anyways, there's a second part to this, or more parts. More parts. Okay, max height. Ah, interesting. Maximum height. So there's something at. Actually, technically, it's like, or even for. I think for S sub x, it's because the time is going to be the same no matter what. It's 73. Oh boy, times 7. Wait, can I find out why this one? We used. I think I have an idea. Oh shit! It's. What is it? 51. 6.5 times. We can skip the final because the final is going to be 0. So that's going to be times 5. What was it? Actually, what was it? 5.26. 5.26 as divided by 2, by the way. Because it's at the halfway. This is the whole trip. So at the halfway point, it's going to be. The divided by 2 gives us the halfway point. So that's going to give us all the way from 1.62 divided by 2 times 5.26 divided by 2. But that doesn't seem right. That's not right at all. Wait, what? Wait, what? Wait. It's without the division? Wait. That makes things more confusing for me now. Does it mean I ended up finding the top level? 135 point, whatever. What was it? What? 76. 76 meters. Why? Where did I get the 5.26 in the first place? Oh yeah, I got it from there. Oh! My dumbass! I said the 0, we finally had the 0, that's why it's the halfway point. Right! Ah! Didn't think. Oh, by the way, this is the B's answer. Something here was an A answer. Oh yeah, this is A. That's A. And then I think this is C. A, C, man. First projector. Yeah, how far it has gone? Well, we already. Well, that's it. No, that's tall. So what's the delta y? Okay, 51.62 divided by 2, 1 times 2 is equal to something. Oh wait, this is a cancel. It's 51. 51.62. So delta x was at 2 seconds was. Do we know? Do we know? Do I know? Does anyone know? Nobody remember. Somebody remember. Oh wait, we do. 147.44. 147.44 meters. Okay, so we know that our triangle is looking like this already. So 147.44. 51. Yeah. 162. And then there's something here, which is the distance. I'm not gonna say it's distance. The distance xy, let's call it xy. Sub xy is square root of 147.44 times, no, not times, plus squared, by the way, time, plus 51.62 squared. What's the sum? Anyways, the total answer here is, drum roll please, 147.44 squared plus 81.62, oh no, squared, and then square root of this. Wait a minute. Is that correct? Was not correct. Why not correct? This is wrong. I don't know. No, there's something. It's wrong. Wait. Did I get the Y wrong? I'm pretty sure I did something wrong there. The Y has to be wrong. Yeah, I don't think I have Y's. No, I don't think I have. I think that's wrong. I think I need the Y's too, but I need... Okay, well actually that can cancel still. But I need some... where's a Y? I need a Y's velocity at 2 seconds, right? What's the velocity of Y? 2. There's a Y at 2. Y final at 2. Wait, didn't I already figure it out? We already had it somewhere. Oh, it's 32. Right? Is it 30? I don't think that helps my case. Actually, I don't think that's helping my case at all. Yeah. This is very wrong here. It's gonna be... Who is wrong? Is X wrong? No. It has to be wrong, right? X, which one's wrong? Also, what is it? I'm gonna clean it away. What is X doing? I mean, 2 seconds is already 147.44. That makes sense. That makes sense. Hmm. Wait. I have a different idea. What if I do delta? Well, not x. Delta s xy. Let's say xy is, what is it? The initial was 90 plus 80.37 over 2 times 2. How much is this? Isn't it? No, that's too much. Displacement. 170, right? 170 something. 170 meters, a point something meters, odd meters. 37 meters, which actually is correct enough. I don't know how that happened. I think the y needs to be bigger. Why is my y so small? Why is y small? Oh, because I'm small brain. Right, I got it. It's because y started at 51.62, but then it added to itself another. No, maybe I'll just do this. 51.62 plus, then the velocity at this point, which was 32, which is equal to 83.62 meters. Now if we take that over here, 83.62 squared, we get the drum roll law. 169.5. This is also relatively close. I don't know whether it's so different though. I guess it's me flooring some numbers or pushing things up or down, but is it very close? Anyways, this is really close, so I solved them. I have solved this question, this very tough question. The weird thing is, I remember my teacher doing it in the most convoluted way possible. And I can't remember how it happened. I can't remember how it goes. But I do remember it being super convoluted. It worked. But this is, whatever I did here is simpler in the end. And I don't know how I got here. How did we get here? Let's review. We found the base case for them. After deliberation, we ignored all magic stuff. Oh yeah, this, I'm just gonna cross it out. Yeah, we found the total time. Oh no, the time at 0. I don't know. I'm still confused how my teacher made it so confusing. I remember there being a bunch of variables going on. It doesn't matter. You disconnect. Give power to the phone. Okay, Canon angle, yep, look at that. Whew. Number 8. Okay, a rifle. Target, okay. 30 meter. The bullet hits target. Okay, there's some target. Maybe I'll make it bigger. Make big target. Big target. And big target. There's a bullet. And then there's a hit. It hit it here. So this delta y equals 1.9 cm. And that's just what you gotta be. That's cm over 1 times is it 100 cm? Take a meter, the meter over 1 meter, so it's 100 cm, so 1.9. 1.9 is 0.1, so 1 is 0.1, 0.019 meters. Oh, that's 0.019 meters. Can you see? Can you? Yeah, close enough. I don't need these numbers anymore. I'm gonna save the space now. Save space. Saving some space, huh? Cleaned up nicely. Alright. So what was the information? Nothing else. No, there's info. Oh. The bullet was moving at some speed. Okay, how long does it fly? Oh. I need to know velocity, which I don't know. Yeah, I was not given velocity. Horizontal. Well. Okay, let's do delta y equals what's the best choice? We can say final velocity is 0, right? We final be 0 because now it's hit the target. And we just assume it's stuck then, right? What is the best choice? Distance. A good formula for this. Where's the kinematic formula? Okay, before I have to rack my brain over that. Nope. What if? What if? What if? I have an idea. Hear me out. I have an idea. Come on, it's a good idea. That's a good idea. I say a good idea. I have more than one choice here. I prefer my choice. Okay, we have so we have VO plus V final. Actually, technically it doesn't matter. Wow. Plus VO. This is by the way the Y. I'm not gonna say that. Times time. But we know this is 0. And we want the VO. So VO. No, V final. Final equals VOY plus 18. Now this we can just substitute. We can do negative VOY is equal to negative VFY plus 80. Now divided by minus 1, we get rid of this whole thing. And so we have VOY is equal to negative, actually it's VFY minus V sub FY minus, let's just say 80. This is also equal to, because for our purposes, this is 0, so we can say negative 9.881 A1T, oh boy, T, and we can substitute here, so we can say negative 9.81 T over 2 times T. So we can do where is, oh wait, what? Oh wait, right, the distance was 0. Does that work? It is working. I'm not sure anymore. I think I'll just see what happens. At this point, I will see what happens. Skipping some steps around just to speed this up. T is equal to 0.019 all over. That might not actually be allowed. I'll fight the bridge when it comes there. Wait, oh wait, because it's double negative, different positive. Of course. Double negative is right. Yeah, the square root. Let's see what happens. Either it's horribly wrong or it's horribly right. Equally terrifying possibilities. 0.019 divided by 4.95. Can you believe it? I am correct. Where is it? 6.2 E minus 2 seconds. Really? Second? That's good. Feels good. I got the time. I got the time applied. Okay, vertical speed. Yep. Okay, the same rifle. What is B? It is A. What is the speed when it emerges? So we in a song equals something, but we don't know what. Can I just initial. Well, initially it's horizontal, right? Hmm? Give the time. We can do something with that. I guess if I find the action Y direction, if it'll help. Let's do the matter. Then we could do checkpoint. We could just do 0.062. 62, which is not time, but velocity. I think that's the average velocity, right? I don't think that's helpful. Is it? Divided by 0.062. That's the total average velocity. Okay, never mind. This is the answer for 187.9387 meters per second. But why? But why? Okay, wait. If it's that the y would be 0, the y wouldn't have changed direction. We can ignore the y. We only need to worry about the x, and the x has constant acceleration. That gives us where's the answer? I had 2. I had 3, but it's correct, but what am I missing? I'm not correct, but also weirdly feel like I'm wrong. Something's wrong. No, the kinematic formula I don't. What if I look in the V average, which is just VO plus VF over 2? Or 3 in the x occupied with these axes. So this gives us VOX over 2. Okay. I don't think that would work. If we double it, it would be the whole time, like just before impact, right? Yeah, looks like that. So this way, it is indeed correct. So our average. Hmm. Hmm. How do I do it? No, I wouldn't. I give it just a hole. We don't want the hole. I need to understand where I'm right and wrong at the same time. Hmm. No. Maybe GPT has some answers. Hmm. Well, okay. Hmm. Hmm. Oh, I don't think my body's working here. Yes, I know. We can do that. Doing magic stuff, please. You completely screwed it, but that's a different problem. Ooh. Um. Um. Ooh. Mm. Mm. Wait, is it a fundamental problem in my brain? You've changed it, huh? Um, what is because the oh yeah, because no acceleration, so the velocities are the same. Alright. So I don't know what the average I was doing here anyways. Okay. What is the average? Huh. Ah, so the one I have is average velocity. Ah, so this how then is the average velocity, average velocity, very city. I see. Very interesting. Right. Okay. Yeah, right. Whatever. I don't need all these now. What? Let me train myself. How many questions left? Eh. 1, 2. Oh, brother. A billion questions. Maybe. Run. Let me try one. Let me try doing one more. I don't know how well I'll do. Wait. Okay. Okay, we have someone throwing balls, basketballs. Okay. Okay, towards the ball at an angle. Wait. Is it? Please, no. Swunk. Swunk. 55 degrees. The horizontal. Make a false. Okay, we're looking at the speed, initial speed. Okay, so well, that's a bit awkward, but it's supposed to be 0.03 meters. And then we have another distance, which is 4.3 meters. And this is where the hoop is. And that's actually the feet. That's the whole feet. So this is the hands specifically. This is 2.1. This dude's very tall, very tall, very tall. This is about 3 meters. This is 3 meters. Okay, cool. We got weather. So let's get rid of the height. So our y is 3 minus 2.1, which is 0.9 meters, and our x is equal to, well, it's 4.3 minus, wait, what's in? Oh, it's 30 cm, so not 0.03, it's 0.30 minus 0.3 meters. So 4.0. So now we have a triangle finally. We have a 4.0 and a 0.9. Whatever we want our hypotenuse probably, maybe. By the way, still 55 degrees. So h equals, or sxy equals to the square root of 4 squared plus 0.9 squared. And we get what? What do we get? 4 squared plus, no, that's another square, plus 0.9 squared. All the way equal to 4.1. Look at that. Like, oh yeah, good idea. Okay, this is 4.1. It's very odd, but yes. Okay, cool. We know that. Hmm. Hmm. Now we're gonna find the initial velocity we must have. But that's gonna have y and x components, right? So how long does it take to get to there? Get to the basket. Zero. Hmm. What do I? Does it have value? Yoink. Wait a minute. That's a minute. Who knows? Who knows? Let's see, how long does it take to get to the... Well, we know the v-axis cosine... v cosine. We know v-axis v cosine... cosine of... let's say 55 degrees. And vy equals v sine of 55 degrees. We need to find the good choices. If we take the 0 point, the highest point, will that give us anything? What if I do 0 plus 80? We'd zero that out. Then we're stuck with VO, which we don't know. And we don't know even the T. We don't need time. We don't know, we know the acceleration, but no times. Initial. We want the initial though. Wait. Hmm. Oh. 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 Hmm. Hmm. Wait, we can, for the x we can use d equals vt. Therefore, we have 4 in the x, which is vt, but vx actually, which is actually t equals 4 over. You could say it's 4x, vx, but that's just the v cosine of 55 degrees. 55 degrees. If we want to find the velocity, if we want to find some velocity, but where do we want to smash this? Smashing. Which kinematic formula do we want to smash? Maybe do the highest point. How long the highest point takes? But we don't. Wait, how long does it take to get to that point? No. I got an idea. Because this is VFY. So it's VO plus AT. But wait, that doesn't fucking help. Does it? I sure shit don't think so. Okay, what do we do? Ooh, what happened here? Never mind. How about the formula y? Does it help to know what the v, knowing that I have a v cosine? We just need to get rid of everything else. Wait, there's a v final type. What's the v final type? There's this version of it. It's somewhere. I think it's supposed to be here. Oh, you didn't tell me. No, you can't do this. Yes, the fifth one. The fifth boy. The unsung hero of the wait. Oh, there it is. The final T minus the final T minus 1/2 AT squared. I found you. And now we get but this is wise. So we got 0.9 is equal to 0. Well, that's a 0 by the way. Minus, well, that's gonna be plus because it's 4.905 gravity, but then times 4 times 4 over v cosine of 55 degrees, so therefore what to do, I could do a I want to get rid of the v cosine 55 degrees one. Is equal to not I mean that's actually completely fair. 0.905 times 4 all over 0.9, that's does it make sense? Something's fishy in my brain. I think something's fishy. What about cosine of 55 degrees? 38 Okay, there should be 38. I mean, let me just do this. My v is equal to 30. About 38 meters per second. Meters per second. Now that we have that, we can just screw everything else. Because now we can see it. If this is 38, if this is 38, and this is 55, then everything else comes together very conveniently. Sine is equal to sine of 55. Well, actually, sine 55. 5 degrees is equal to opposite over hypotenuse, which means y over 38 meters per second. Oh, velocity in the y direction, right? And that's equal to 38 times sine of 55 degrees. Degrees. And Vx is Vy and Vx. Let me actually do it this way. Sine of 55 degrees, 38 times our cosine of 55 degrees, and this gives us. We didn't already find the answer. I think that was necessary. No. I think I got something wrong. But what? Oh wait. How did I forget? This is squid. Whoopsie. Ooh, whoopsie. Oh, whoopsies. That becomes. I'm just gonna say, just do this little part here. 60 squared. No, 60 and 4 squared. I think we got. I'm just gonna keep these. Nah. No, we can keep them as a square. Cosine 55. Cosine 55 degrees squared. So we can have this as a square cell. But then we have we can have the we could have v cosine 55 degrees is equal to the square root of 38 all over cosine of 55 degrees. The same happens here, cosine of 55 degrees, so cancel those, and now we get all the way to, what do we get? 30, no, square root of 38 divided by, wait, it wasn't 38, 0.904 times 4 divided by 0. Divided by 0.9. Yeah, that's 21.8. 21.8. Could be 21.8. 38 was if I used cosine already. Thank you. Wait, what do I get? 21.8. No. What's the square root of that? And then the holding divided by cosine of 55. Is this correct? Dude. Oh. No. I said no. Was anything wrong? What did I do? How could I do? How would I be wrong? Wait, I'm a fool. Am I? Yeah, probably. Yeah. I think I keep forgetting numbers. Okay, this is way too confusing. Screw this. That's 16 squared. So times 16. That would be yeah, divided by 0.9. Would that work? Is that more correct? No, can't be. Cannot be. 4.905 times 16 divided by 0. Yes, no? Oops. No. What have I found? What have I found? No. Something's wrong. Something's terribly wrong. How would I? Wait. Did you choose? Hmm. Hmm? What is it? Fine. H 19 divided by wait. 5 point. Gosh, mate. There we go. Crap. No way. There's no. Yeah, that's no. Dude, something's wrong. Hmm. No. No. Something's off. No. Target speed? No. Which is why is caps lock on? Caps lock. Stop autocorrecting me. 905. 15 to the power 0.9 all to the version 30 MP. That is all. Point. A point. Oh. Yes, be more. But no. At that point. Yeah. Hmm. Hmm. Where the 4 come from? Alright. Four over. Hmm. 5 degrees. War. Isn't it just final? Is it the final? Hmm. No, that doesn't make sense. No, that is. No, I know something's wrong. Hello. 4.9. Something is actively wrong here. Zero. Plus. 0.9. The square. Let's think about this. Hmm. Change anything. Let me be thorough. Let me try to be thorough. 4.905 times 16 over v cosine 55 degrees. Yeah. Then we can get we can times the v cosine away, or so we get v cosine 55 degrees squared times 0.9 to the 4.905 times 16 and 0.9. And we get something square root and then divide by it. Something's wrong about it. What is the answer? Where's the answer wrong? We find some other velocity actually. Which have 55 degrees. Is that the total? Or is that the max? Or the end? What velocity is it even anymore? Point in time. Okay, different idea. It seems broken. Oh, why did I get 38? I think there's something completely unrelated. Allowed. Try something completely different. Let's see where the answer shall lead me. If you assume d equals vt, you can presume. Isn't that vx though? It would be the x version. Huh. Right, I use the time to get there. Time. Right. Wait. No. Wait. Go again. That's not it. Is that total time? Is it? Where's the... Let's be sure, by the way. Cos 55 equals Vx over V. And then times V. So V cos 55. Vx divided by cos. So Vx over cosine. No. Wait. Now this is Vx. Right. We want Vx cosine 55 to be there. So I was correct about that. Judging by hypotenuse. Move. I wish. Actually, maybe if I just, for now, just make a crap. It keeps happening. Boink. This is too destructive. And leggy. How did you even do that? Wait, that's all useful. Oh, jeez. Why'd you do that? What'd you? Somehow I decided to rotate this off. Let's screw that. Wait, what? You? How many times have I told you not to be so huge? Oh. I had to go back in time. Good thing I chose this as the last one. Yes, that's good. Good stuff. That's 0. So let's go back to 0.9. Wow. 0.9. 0 plus 1/2. It's 4.905 times what was it? 4 over v cosine 55 degrees. This squared, but if this is squared, then that's just 16. Can you actually times it? No, I gotta give it to a calculator. Alright, I got something. Maybe. Let's see what this happens. Equals 5. 16. Oh wow. 1050. Do I have a degree symbol? Oh. Maybe we can degree. Got it's been 2 hours. Oh wait, there's a degree symbol over there. Thank you. Oh wait, you fool. How could you forget? I don't mirror you if you don't soon start working. Hey, the big parentheses, yes, great. Let's solve it again. What the hell did you get there? Oh wait, what? What happened there? This time. Yeah. Oh right. I wasn't wrong about the previous, but something's off about it. Where's the velocity I found was 16.28. Why is it wrong? Something's off about it. But why? But what? Do, 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 do. Is it the final position? No. No, it's halfway point, right? No? Yes, maybe. Maybe it's the halfway point rather than anyone else. But that still doesn't fix the issue at hand. Let's try something else. Let's go back to the drawing board. No, wait. No, no, I've been doing it wrong this whole time. Perhaps. What if we screw this and say, because we want to find the initial in the first place, so we can just do negative VOY equals we have OY plus AT. Oh, this is negative by the way, so negative. We get V final Y minus AT. I can sign some so 0.9 equals what do we want? Final though. Final wouldn't help us, would it? Already, do I know final? No, final is 0. Is it? No, wait. Well, after the halfway point in the first place, so let's just say it's 0. So we can have a negative 80 negative 80 times t minus is it plus minus plus minus plus plus? I think it's plus 1/2 AT squared 0.9 equals negative t squared. It is squared plus AT squared over 2 . So let's just figure it out. 0.9 equals negative AT squared. Wait, it's actually 2 over 2 plus AT squared over 2. So 0.9 is equal to negative at squared over 2. So this is just 0.9 equals negative 9.81 t squared over 2. We could say 9.81. So we are left with 0.9 is equal to negative 9.8, actually plus 9 plus 4.905 t squared t squared t is equal to 4.905 square root. Ah crap. No, I didn't change it. This how it works. I can construct my own. Yes, if I want to do the 4.95, the square root of that. Assuming halfway occurs for 3 or 2. Closer. About 3. Second. How long it takes holding? Total time. I wonder. Reacts. So we could say 4.43 reacts. So we get 41.3. It was 9 point what? No, what is it? 302? Does it make sense? For right now. I think there's something off about that. So, 0 with here. 0 equal plus. This is minus 9.81 times 0.43. So we can get a positive value if we just move things around. 9.81, 0.43, 0.21, 1. Maybe try and figure this out. Maybe close to what it's supposed to be. What? When did I press that? Crap. Poop. No. No. Wait, what? Oh, no. 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 Actually. No. I guess just no. The hell? About the halfway point value. No. Something's off. No. Something's off. What? That would be the initial 0 point. When that would get that's constant, right? No, that didn't work. There's something off about it. Must be the previous position. Previous thing. Ooh. Do 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 do. 0 point. Halfway point. So 18 times time. 0 time. Time. Squared. Weird. Right. Square. I think. What if I? What if I really figured something out? Really? Uh, what's wrong? What's different? Okay, no. This one is 0.6. Did I make a different mistake? 9 about square root of 9. We got 4.905. Wait, that's wrong. Ooh, in this perspective, that's going to change it. We could just go on. Speed rail. Prior speed. Somebody speed rail, no? No. No, it was correct. First time. Why? Hmm. Hmm. Good point. Hmm. Where is it? Oh, you don't understand. Existence. No. This isn't worse. It's stop. Hey. Oh, what if? What if? That's not it. That's not it either. No. Define what position. What is that? We need to be at the final. Either. If that's the final, then makes the bigger problems. Hmm. 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 So wait. What are the zeros? Hmm. No. What's wrong? What is so wrong? Oink. There's something terrible. How do you come back? There's something terribly wrong about this. Deliver the halfway points. Yes. What if? What if? We did this VG. We already figured that out. Let's figure it an initial. Hmm. I'm somewhere in the rain. I'm getting it. No, I'm not. We can replace certain values with this. Hmm. No, we can't have V0. Okay, what if we go back to the whole idea? Okay, I know it's stupid, but let's go back to the whole idea that we finalize 0. Therefore, we have 4.905 times the 4 over 3 cosine of this holding squared with. Hmm. Hmm. Completely different idea. So, what if 5.9, 9.81, 9.81 times 4 over 3 cosine 5 degrees times 4 cosine is a holding for 5 degrees. Oh, we. Oh, we. Wait. What did I do there? That's time, right? Time. This is why, by the way. Time. Minus 4.905 times 4 over v cosine 55 degrees. Weird. And then we get a bunch of weirdness. Please get 9.81 times 4 times 4 all over this v squared cosine 55 squared. Maybe I should. Oh god, I don't know where to put it. There. Minus 4.905 times 4 all over. Oh wait, 16 all over v squared cosine 55 degrees squared. Okay, maybe we can. Maybe this will make something new. Create something new. 9.81 then 4. Minus. Wait. Nah, whatever. 905 times 16. 8.40. How about that? 8.48 with some what? V squared equal to yeah, 78.48. No, cosines go 55 degrees all over times 0.941. Maybe no, it's 0.9 to get it there. We get it here. I will need to divide times 1 over 0.9. Right. 9. Right, that's whole. Point 40 time, no, divided by cosine 55 degrees. Okay, this is gonna be weird. Squared times 0.9. I don't think this is going anywhere. It's still going to be 16.28. But it's still wrong. I can't remember why. I can't figure out why. Why? Why the why? I used the initial. Put it somewhere on top of the initials and crafted a 8.14. Is it 8.14? Let me show you. No, I think I just need to find the. I think I just need to find the VX. Oh, that can. VX. This is 4. Oh. Hmm. No. 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 Yep. There's something completely wrong about this. Something off. No matter how I do it, it just doesn't hit the correct values. Boink, boink. Uh. Let us reconsider from the get-go. What if? Why you? Why did you disappear? 401. Time. On. Event time, but that doesn't help me, does it? Final time. There's 0%. You have to be less. Okay, no, something's wrong. Something. I guess at this point I can think about it. Start using cheat sheets. Need to get one information. No, that's completely wrong. Mm. Oh, wait, right. Okay, so with this, we're going to find the V initial. Let's just use the initial here. Initial. And it was for V initial version of the target. Nice. Wait, what's the problem that I'm making? Alright, completely forgot that the initial, yeah, maybe I should use 0. Initial y is the sine of 55 degrees. How could I forget? Anyway, anyways, now that I have that, I can already solve it. I can actually probably solve this right. Look at this little buddy. So v sine 55 degrees times 4. Well, let's hold times 4, not 4, but v0 v 0y. No, no, this is v sine. It's also v sine. Well, 0 sine. No, that's cosine. Cosine of 55 degrees. Okay, yeah, I think I got it already. 1/2 times. No, wait, there's a. Let's just do plus 4.905 times 4 over cosine is 55 degrees. Also, it's a velocity. $55 degrees over that squared. Alright, anyways. This is basically we well, we can have, we could have VO. Okay, so it's a bit confusing, so let's just do 4 VO sine and a 4. No, so where? Okay, we can just do times sine of 55 degrees over cosine of 55 degrees. This will help us a lot. Now we get 4.905 times 16 over v cosine 55 degrees squared. Oh, this gives us that. Oh yeah, that's a no initial, by the way. This tangent. This is VO 10 of 55 degrees plus. Yeah, what's next with 4.905 or 16 all over V. But didn't those guys cancel, by the way? So we have only 410 over VO cosine our degrees. Times 1 over 0.9. Gonna presume like this. 0.9 was used to be here, but that's gone. So we can do, actually, screw that. That was a bad idea. 0.9. Whether this is squared. Hmm. Oh. Maybe I screwed up with the whole plus. At the plus part, huh? Okay, just for simplicity's sake, I'll do 0.9 minus 4 tangent of 55 degrees is equal to. Let me just do times 1 over 4.9 times 16 is all equal to V0 cosine 55 degrees all squared. Ah, crap. When I did that, it left this with a 1 over. Version. Crap, never mind. I don't like that. Just like times this a VO cosine of 55 degrees squared is equal to 4.905 and 16, and finally we get V0 cosine 55 degrees is equal to 4.905 times 16 all over 0.9 minus 4 tangent of 55 degrees, the square root of this whole thing. And then finally we get V0 is all of this, all of that. I'm supposed to, is it like this? Right. Inverse cosine 55 degrees, which is finally, hopefully, is correct. The square root of 4.905 times 16 divided by 0.9 minus 4 tangent of 55 degrees. Ah shit, what happened there? I think there's something terribly wrong here. It can't be that. Oh, what happened? What went wrong? Ah, these is also mine, so they cancel out in the end, right? So 4.03. All of that business divided by cosine of oh, it's so 7.04 meters per second, and it's correct. Oh, Jesus, it's correct. I cannot believe it. Now, only one thing left to do, which was to test out the previous method. Because I get suspicious that maybe I would have everything would have worked had I done them correctly. Okay, no, I don't think it would have mattered. I don't think this would have changed anything actually. Because we found y plus 18, no, it's minus 80. So when I did this 0.9, we have, well, it is negative 80 plus wait, minus, no, minus, plus, minus 0.905 4 over v cosine 55 squared. So 0.9. Wait, this t should also be for 18. Oh yeah, times t. Wait, what? Because you do that? Wait a minute. Wait a minute. No. No. Nope. Previously. 80. No. 1/2. Maybe I have a fundamental problem there. I had in the past. Before I got it correct. Obviously. Yeah, okay, no, never mind, it was correct. Negative 80 squared over, well, 280 squared over 2 minus 1. Well, let's say it's 1/2. 82 to 2. This is 80. Wait, was it plus? Plus minus plus plus. Is it plus? Use the initial. Wait, am I wrong about that? Look at my public. I was correct. So it's 80. 2 so 0.9 times 2 squared. 2 squared. No. And a 2 divided by 8. Hey, 1. 2 squared. Negative? No. Negative? Negative. Oh, it pluses out. Yeah. Yes, I think that's bigger 0.43. What is it? Actually, does it? Point 9 times 2 divided by 9.1. Square root. Yeah, 4.3. 4.3. Oh. Oh. Hmm. Uh, does that make any sense? Read 30. Nope. Still did not make any sense. I think it's because it keeps finding a different time. No, it keeps finding the halfway point time. But not even the initial. Some other point. I think. Yeah, no wonder. It keeps finding some other point in time. I think that's where all the problems start. It's not even the initial. I think that's was the problem the whole time. Whee! Anyways. Yeah, this was the answer. Oh yeah, but oh wait, right. The 55 degrees only works for the initial, because after that the degree changes. Theta changes. Degree? Degree. The angle changes. I wonder, was I working at all? It works. It all works out, right? Well, I mean, I got the answer, so that's all. Cool. Yeah, I just had to remember that what the V or the Y was. That way I could have I managed to construct everything. Right. If I remember the V initial for Y, then I could have constructed this whole equation a little sooner. Anyways, I am not doing any more for today. So goodbye. Bye bye.